I thank ACCI Hyderabad Center, Instruct and Shapoorji Pallonji and Company Private Limited for giving an opportunity to share the experience of one of the most challenging and I can say high-tech composite construction which was done from 2015 to 2018 for Intel, a major corporate giant in Bangalore. I also thank Sri Rajkumar, Sri Ramesh and his team for excellent hospitality and whatever the logistic issues, logistic coordination. I thank Mr. Rajkumar and his team. As we all know, composite construction involves combining two or more different materials to create a structural component, leveraging the advantages of both the materials. So generally, we all know RCC is how good a material is, and it is the most vastly used construction material. Similarly, composite construction is taking steam. It is gaining momentum in construction because of a lot of other advantages it has. And most common composite construction combination is steel and concrete, where steel provides tensile strength and concrete excels in compression. When we look at composite construction, the key aspects are combining material, enhanced performance, and cost effectiveness. Of course, we are utilizing strengths of various materials which are combined together. Now, we are restricting today to steel and concrete. And why it is so important? Because the performance by combining these materials will result in elements which increase strength, stiffness, durability compared to a single material. And over a period of project life cycle, it is cost effective, even though initially we may find composite structure construction is costlier. But over a period of lifespan of the building or the structure, cost effectiveness is definitely there when we go for composite construction. And of course, speed is one of the most important parameter. Shapoorji Pallonji and Company, as I shared, executed the design and build contract for Intel SRR3, Intel SRR4, and there was one more composite construction we did, that's called SRR5, which is India's first composite multi-level car park, housing around 2,300 cars. So we were the general contractors, and I am not going to deal with the design aspect, even though the contract is design and build, because I am not having that capability to talk on design, so pardon me. So both Intel SRR3, 4 and 5 adopted steel concrete composite, and each I am restricting today only to the vertical high-rise building. SRR3 and SRR4 involved design and build of around 6 lakh square feet each of an IT office and laboratory space, and it was ground plus 9 upper floors, and its overall height of around 50 meters. The most important aspect of this composite construction is innovative top-down construction technology and the structural system. We might have heard top-down construction when we do this basements or diaphragm wall construction. But these two buildings were in real sense top-down construction, because the roof was assembled first and the ground at the last. So this is, till in India, I don't think anybody has done this kind of building. We were fortunate enough to do such building. So the whole idea behind this kind of system, adopting this system, came from Intel. As we know, Intel drives innovation. They used to drive. But of late, due to market fluctuations, due to smartphone, tabs, they are really not able to cope up with the innovative edge they had. So they wanted to show the whole world that they are still innovative. And that is where they wanted to market this, that they are still leaders in innovation. So the result was top-down construction, which was done in New York for High Commission, Russian High Commission building long time back. After that, it was not used elsewhere. And this was patented by AECOS. So in SRR3, the first building we did, the contract design was with Intel and AECOS, and we were general contractors. So when we did SRR4, it was both design and build was transferred to us. So it is basically, when we do top-down construction, we can lift the slab with all MEP undertaking services done and fireproofing done, all interiors loaded, and it will go in, and including the facade, and it goes and locked in position. The inside becomes absolutely enveloped area and a very safe area to work. So even impetus on safety was paramount for Intel, and I will discuss later on what were the benefits. So innovation, reduction of timelines, enhanced quality, because it is what we call DFMA, design for manufacture and assembly. That technique was adopted here or just in time. And of course, as I have informed, it was the most safe work environment you can expect, because there are no scaffoldings, nothing. There is a stair which leads to the floor directly, and the floor is enveloped. So this is the actual photograph, how it looks. Architects were Thomas Associates. Structural engineers were TT, Thornton and Thomsetti. MEP was designed by Design Tree. Built-up area is 6 lakh square feet each. Project duration, we took 18 months for SRR3 and 14 months for SRR4, which if we had approached with conventional construction would have taken anywhere between 24 to 30 months. So this is the advantage of having gone into this, and there was a profit sharing contract also. When we did SRR4, we finished 1 month ahead of our target of 15 months, and believe me, we were rewarded with 27 crores of bonus. So I am just combining, crisscrossing SRR3 and SRR4, so please bear with me. So this was the logistics. SRR3 was the first project. We all know Intel's campus on Sarjapur Ring Road is a horizontal building. SRR1 and SRR2 are only ground plus 3 floors. So we have A1, A2, A3, K, which is called knuckle, where all your reception and lobby is placed, B5, B6, B7. So A1, A2, A3, K4, B5, B6, B7 are all cores. So there are 7 cores, which was slipped ahead of the floors. So it's an L-shaped building. It has got wing A and wing B. Each wing is 90 meter by 27 meter wide, and it is joined together by knuckle, which is 27 meter by 27 meter. The floors are cantilevered from 7 structural concrete cores and positioned at the required level by built-up locking beams when it comes to SRR3, and through steel plates suspended through hat trusses in SRR4. And the transfer of load onto the 7 structural cores happens through this system. The cores, all the cores accommodates elevators and lifts. And the office area is absolutely column-free structure. How did it work? Top-down construction, steel floor is assembled, steel fireproofed floor is assembled. I will explain you, I got a video also. Then we lift it to intermediate position, do all the underdecking and MEP works, fireproofing, and even the glazing is installed. And slab is loaded with all the fit-outs required for that particular floor. It is lifted and locked in position using heavy-duty jacks, and we utilized jacks from Fijioli. The key components: isolated footing for 7 cores. All the 7 cores are individual footing, 7 RCC cores, and composite deck slab. The sequence is something like this. We had foundations. There's the first stage. Then slip form is set up as the second stage. RCC cores using slip form technique was the third step. Installation of trusses and strand jacks at the top of the cores. Then roof assembly and slab lift, interior fit out, external development, and the completion of the building. So these are the on-site photographs. There are 7 number of cores. I mean, there is a little difference in the design of foundations. I'm not going to go in detail. Whatever I'm showing is SRR 4. So there were 7 cores, and each were having mat foundations of 20 meter by 20 meter, and the depth is 2 meter average. See, while doing this, we never envisaged the temperature differential and the thermal cracks which would result henceforth. So while we doing, I think, second or third core during probably summer, first 2 cores were done when the temperature was normal. During third core, we noticed some cracks, thermal cracks, due to differential temperature, because at the stepped footing, which is done as an overhang shutter, the depth would have become 2.5 meters. So there will be definitely a temperature gradient between the core and the top surface. And I mean, it was just an experience to us. I am talking about 2017. We started doing classical curing using water, and suddenly we saw a lot of cracks on the surface. So, of course, we did epoxy grouting and we ensured monolithic construction, but then we understood the real reason. So instead of curing by water, we went in for insulation to maintain the temperature differential well within the required level of 20 degrees. So planning, a lot of planning happened, and why we chose slip form? Because if you go for conventional construction, it becomes very difficult. And doing slip form, you get a continuous surface and a jointless construction. And of course, if there is any issue in slip form, definitely we had it, because you have to dismantle, reassemble. That's a huge risk. But to mitigate this risk, we handed over the entire project to Slip Form Dubai, who are having a lot of experience of such slip forming, because this was a very prestigious project and we did not want to take any chance. So based on the schedule, we were supposed to finish course by 100 days. We deployed around 3 sets and a knuckle. Knuckle was separate because the shape is different. So we used 3 sets of slip form, so that at any given point of time, there are 2 cores which are in progress. So this is how it is. Core size is 7 meter by 9 meter. You can see the outrigger columns That is for SRR3. In SRR4, we modified it and we eliminated the outriggers so that that much of complication is reduced. Core height is 46 meters, wall thickness of 250 millimeters, and we used outrigger beams. Also, beams and column. Concrete per core was not much, but it was very challenging. 500 cubic meter, and total 7 cores, around 3,900 cubic meter of grade M60. Reinforcement total was 125 metric ton. There are a lot of embeds and inserts, close to 100 metric ton, you can imagine. So the key for success of this course were how accurately we fix the embeds. Because everything in SRR3 especially, the entire weight of the building is, entire weight of the floor is on 4 interlocking beams at each core. So if we don't have that accuracy and other embedments, it would have been very, very difficult. There are a lot of cutouts in cores. So around 80 cutouts were there. So slipping was a critical issue because it has to slip without any break. Grade of concrete, as I told, is M60. And we chose slip form for schedule, for speedy construction, good quality of construction, and safety standards. Because we all know when we do slip form, we have 3 decks, and there is absolutely safe working environment. It's as if we are standing on ground and working. So this is how it looked. Top deck, working deck, and hanging deck is schematic on the left side, and what is actual on the right side. So you can imagine there is no issue of safety, no threat of working at height, and any safety related faults or other things. Coming to challenges. So slip form we chose, everything is fine for us and for the most of the stakeholders. This project was a first time. Even though we had a lot of international associates, the patent was from AECOS UK, US, then the geotechnical consultant was from South Africa. So we used to do a lot of coordination while doing this construction. I will touch upon it when it comes. So main issue was how quickly and how accurately we construct cores. Once we do the core, then rest is easy. I mean, rest is all mechanized, and it's easier because if you ask me, concrete is the most complicated material in construction. This is my experience and understanding. Whatever may be the grade, irrespective of the grade, to handle concrete, it is extremely difficult, and it is the most complicated construction material. So we have to arrive at workable mix. There are a lot of constraints. First of all, M60 grade. It's a high grade core, and getting M60, meeting the requirements of slipping was a great challenge. We have almost conducted close to 200. I have account of 120 combinations of trial mixes. So before we started course, the planning would have been easily 5-6 months. So close to 200 trial mixes were carried out to attain desired strength with the limitations. I will tell you the limitations. Slip Form Dubai, out of their experience, they were very clear. No PC-based admixture, okay, because it causes stickiness. No microfines. So we were supposed to do only with OPC and GGBS, and with first generation or second generation admixture. So that was the biggest challenge. So that's why we used naphtha-based admixture, RioBuild 1100. So you can imagine the difficulty. Even today, without high-range PC admixtures, we are unable to get M40, M50. Why? Because to accommodate non-sticky surface when slip form slips. And because of lot of embedments, we require a lot of time to have these embedments. So we estimated that time to be around 6 to 8 hours. So our final setting of concrete was very critical to slip. So we designed, after a lot of trials, we arrived at a mix which would give us 8 to 10 hours of setting time. So that in meantime we can complete all our reinforcement works, all our embedments for the subsequent lift. Water cement ratio was 0.35, slump around 200 millimeters, 30% GGBS we used, no glenium, no ultrafine material, RPC based admixture. So this was a real challenge. And we also simulated on ground how actually it performs. So as I've explained, 8 to 10 hours we thought is the correct time to allow other things to happen meanwhile and to before slipping. So even we simulated the slipping, you can see that. And we were successful in arriving at a mixed design which has got strength of M60, which has a functional requirement of slipping. When it comes to SRR4, outriggers were removed and hat trusses were introduced. So these hat trusses will carry the entire load of the floor. So that's why the seating of the hat trusses was to be higher grade of concrete, so they wanted M80. But fortunately, that was the end of the slipping, so that once you reach below 2 meters, next is only removal of shutters, so there is no slipping. So we were fortunate enough to use microsilica or alcofine and glenium admixtures. Otherwise, it would have been very difficult. So this is the mixed design details we have. See, the quantity of concrete when it comes to multi-storied building done in concrete, it is very negligible. But the amount of challenges we had was enormous. Because once slip form fails, it requires easily 2 to 3 months. So you are out of schedule by 2 months. And you have to do consistently for all the 7 cores. And because of this extensive planning and the extensive brainstorming, I am standing here today and telling it proudly that we are not even stopped for a single second. So once we started the core, it went up till it is finished. For both the projects, we had 14 such cores. So we have simulated everything. One is slip forming, second one is deck slab, third one, how do we lock it. So you can see a lot of embedments. These embedments support the locking beams on which all the floor load is resting. And concreting is done using buckets. We first tried on the left-hand side, yellow color, not a normal bucket. We used to call it as banana bucket because of its shape. But we are still not getting, there were a lot of spillages, lot of difficulty in handling. So we imported the automatic gate, closing gate, discharge gate bucket of 1 cubic meter capacity from Italy. So a lot of thought process has gone in making this construction a success. So these are the cycles. So you can see each 250 mm is taking 1.5 hours. So after 6 hours and it starts the initial setting, then only we lift it. And subsequently, the other layers will get gradually the initial final setting strength to operate and lift. So this is the advantage of using slip form, because you in the one is top working, below you can attend to all issues related to concrete. Unfortunately, we didn't have any issue. We used curing compound, and even if you go and see, the concrete surface is really good. And the challenge is, we all know, verticality of the cores. So we have extensive monitoring of verticality. We have fixed 8 points for each core, and we use plumetometer to check and record the shift. So either north, east, south, west, all the 4 directions. And we used to plot all these things, and the readings were taken in the interval of close to 300 mm. Once 300 mm it slips, we take all these measurements. Like this for one core, like this, all the simultaneous cores. So in SRR3, the slip rate was 2.57 meters, which was improved to 3.15 meters in SRR4. So in the perspective of the measurement, it looks very, very insignificant. But we all know as civil engineers how difficult it is to even improve by 10 mm. So from 2.57, what we achieved in SRR3, we modified and did the slip form completion with a rate of 3.15 meters. This is how you can see excellent concrete surface. No honeycomb, no segregation, nothing. You can see how much of openings are there. And we had our own doubts at the start of this project whether we will be able to do it or not. So that was the challenge. It's a very small quantity as concrete, but the difficulty, the constraints in making it happen still makes it as one of our largest accomplishments. You can see in SRR3, the tolerance was plus minus 25 mm by design, and we could achieve, except for stray cases, most of them were plus minus 15 mm. You can see in SRR4, 98% of the tolerance, shift tolerance, was within plus or minus 15 mm. This is the strand jacking arrangement. We partnered with Fijioli. All quality assurance, quality control was done immaculately. Even third party certified the jacks used. Close to 60 jacks we used of various capacities, 450, 300, 180, 100 metric tons. So it's a combination of, and even the structural assembly for composite slab, you can see how accurately every torquing was checked, confirmed, and approved. Then only the further things will happen. You can see, we will sign on this structure. On left hand side, you can see it's all computerized lifting mechanism. Each jack, you can see the position. And right side, this is how, when the deck slab is lifted, when we are going to release it, what are the checks involved. So the key to this success is absolutely doing things right for the first time. Otherwise, with the challenges what we faced, it would have been highly impossible to achieve this. So you can see the difference. You have outriggers. On outriggers, you have the jacks in SRR3, and in SRR4, you have hat trusses on which the jacks are installed. See, the major, I was telling you, even the lifting operation was easier in SRR4 because number of jacks to balance is only 4 per core, whereas there it was 8 per core. So that much of balancing, you lift it, you have to check, then only you have to lift again. Otherwise, differential lifting will cause problem. So that's why SRR4, because of various such measures, we could reduce the timeline on SRR3 by almost 25%. This is how the slab cycle lifting, 18 days were assumed, and how it happened. And why 18 days breakup is also there. First 6 days, next 6 days, and final 6 days before it is lifted and anchored in position. Everything was based on mock-up before doing the job, and having planned well is the half battle won. So this is what the interlocking, you can see the I section. It's all 50 mm thick plate. So that interlocking which goes into the notch, I am not able to explain to you very clearly through pictures, but the notch we had in the core, it will go and sit exactly on that, and the entire floor rests on that. So even that, once the cores are done, we have done the simulation of that particular locking combination also. Whereas in SRR4, it was much easier. I will show this. So you have tongue and groove. You can see while along with the hat truss, you have got 2 plates which has a tongue and groove connection, and in the floor it is getting connected and bolted. And each bolt is torqued to its requirement and checked. So this was much easier compared to the locking beam arrangement. So this was one of the improvements which was responsible for reduced schedule. This is how it looks. This is the deck slab. And you can see even the brackets are installed at ground level for facade also, and facade is also fixed. So these are some of the key elements of this construction. And coming to major challenges. First thing, none of us in India had done this. And whatever was done was quite some time back, 3 decades back. So you can imagine how advanced the other countries were and are. So what they have done in 1971, we reproduced in 2015 after 45 years. But still, the generation had vanished. Only TT was the common point, and AECOs had this patent of top-down construction. So technology know-how was very, very limited. And how did we mitigate this? People will agree with me, because all of us are practicing engineers. If you plan well, definitely you will succeed, and your 50% of the problems are solved. Believe me, close to around 200 people all over the globe. As I have told earlier, Indian participation was very, very less. It was only to client and us, plus some MEP consultants. Rest are all global. Everybody traveled to Bangalore. We had 8 days of charrette, full sessions. We booked. It was done in Taj Vivanta ITPL. From morning 8 to evening 6. You know how Westerners work on timing. 8 means 8, 6 means 6. 8 days to iron out how do you go forward, what is the best possible way to move forward. And once we completed SRR3, we had 4 days of similar exercise to understand what improvements can be done to reduce the timelines and to get a better quality. So these 2 things helped us to a great extent, and we could able to achieve what was wished. From SRR3 to SRR4, 450 improvement initiatives, whether it is big or small. I have listed 3-4, but there are very, very distinct minor improvements also, totaling to 450. So whatever you say, Kaizen, every approach was done informally. And we could reduce the timeline by 25%. And it was a win-win situation to both client and the contractor. Results, cost and time. What could have been taken 26 to 28 months, SRR 4 took 14 months, SRR 3 was 18 months. And we partnered with JSSL, Jindal Severfield, for all these structural elements, and everything would arrive just in time. So, lot of quality control because everything was manufactured, and less safety hazards. There was no tower crane. Everything was using luffing crane. And labor, you believe me, this kind of conventional, all of you would agree with me, conventional construction, peak time, the labor capacity will be minimum 800 to 900, whereas we did it in 300 people. Very safe and very fast construction. And building design also, because of this, was very efficient, because except for cores, all the floor area was column free, obstruction free. And because composite construction seismic performance is much better, I am not an expert on design, and the flexibility to alter the space according to the changing needs of the customer was addressed because there was no obstruction on floors. Construction, to achieve this quality by in situ construction is next to impossible, even today with a lot of advancements, and every aspect of conflict was captured on BIM. When it comes to safety, I have already highlighted, we clocked 6.5 million safe hours for both the projects, and the people were so comfortable, they were as if they were working on ground. One during slip form and during finishes also, they were in an enveloped environment, and wet works were reduced to a great extent because we all used drywall technology even in toilets. Quality, of course, it is designed for manufacturing assembly just in time, factory controlled environment, slip forming, all these things, and better safety, all these led to super quality construction. So to conclude, adoption of this top-down construction has reduced cost, reduced time, better schedule control, better quality, and considerable reduction in risk and hazards. Once again, thank ACCI Hyderabad, Instruct, for all their hospitality and the opportunity given to us on behalf of Shapurji Palanji and Company Private Limited. Thank you.